Right, so I found a bit of energy today to get this thing wired up and got the wires hooked up. But my solar battery has been on balance charge for about a week actually, because it's a 147 amp hour lithium battery pack, which I made, so it takes forever to charge it at half an amp, which is what it's been getting triple charged at. Well, half an amp at balance charge, so don't expect to see a lot of high current on the output. What we will, we're going to be charging the supercapacitors, which is a good thing, because I was thinking earlier, oh damn, I'm not going to be able to really get decent current on this thing because the battery's already charged up. Then I thought, actually if I wait for the supercapacitors to discharge a bit, because they're at 4 volts right now, up across the room, they're at 4 volts, so yeah, we should see a fairly decent current. I've got to get this thing running. Now bear in mind, I haven't actually tested this since I put the new lamination arrays in the device, and the new concentrics that are put in the base section. So it's going to reduce the new concentric magnet arrays, which are in the front end, I should call the front end of the magnet and the coil array. Because they're right close to the rotor, they cause a little bit more drag than I like. So we've got RPM meter there, we've got current draw on the input, and we're going to be running at 23 volts, or 22.99, 23 volts it is. So I thought, well, let's do a little test, but I might have to swap wires around on here to optimise things, because these aren't really set up right. But what I've done, because the sockets on the generator, they're a little bit picky about the diameter of wire that you stick in them. Although if they're loose wires, I can't just stick the wires directly from the coils in because they're too thin. So what I've done is I've soldered these thicker wires onto the thinner wires. I don't know if you can see that, probably not, but I've soldered the thicker wires onto the thinner wires that go to the coils. So and the stages of coils are basically, you can't really see the coils at the back. The first stage of coils goes to this one, the second stage of coils goes to that one, the third stage, the back one. The third stage goes to this one here, and the fourth stage goes to these coils here, so they're actually sequential. Now, one thing I didn't really try, was alternating these, and that might be interesting to stagger them, so that we have first coil, then third coil on there, then second coil, and then fourth coil. That's something I've not really tried yet, and that could be an interesting intersection of staggering the coils, and yeah. But anyway, I want to get this thing started. Just give me a minute. It's a lot easier to use my mini drill. Let's see if I can do it at 6 volts. Oh, I haven't turned that on. Oops. Oh, it's going. Right. So I'm picking up speed, there's current there. That's output current that goes to supercapacitors. We need that to pick up. Bit of dust on here actually. Got a lot of dust. Well, it's climbing anyway. Oh, the LED's coming on now. It's starting to fire. The tracks are starting to fire. That's good. I want to see the RPM get up to around 4,000 RPM. So about 48 milliamps. We're still climbing. Let's twiddle these pots a bit. Right, we're at 50 milliamps, we're still climbing, speed's still going up. Take some switches out of the circuit. Yeah, I expected the current to be a little bit lower. Oh. Just check my audio settings. We're not really pushing as much current out as what I'd expect. I might have to take the concentric magnet arrays off the bottom end actually, because they're interfering too much with the flux lines coming through on the front end of the coils. What we can do is alternate these coils. Now let's look at RPM. It's about 4,188. Let's alternate these. I want to try alternating these, switching around, because that's one thing I haven't tried yet. Can I get them in the hole? Oh, that's interesting. What are we at? 30 milliamps. Let's get these in there. Interesting, 47 milliamps. Can't really move this one across here, the wire's not long enough. I didn't make it long enough anyway. I could alternate that one with that one, because I'm trying a few different things right now. It's interesting to try these things out. And actually that's got a bad connection somewhere. Stick that one back in there for now. That was at 50 milliamps just then. There's also polarity reversal. Let's swap that one around. Basic recycling, that's worse. It's all about getting phase matching. You've got to try a few different things, obviously. Yeah, that's worse. Let's try reversing this one. Damn it. My wire's stuck. Oh, my tweezers. What's that? 22. Oh, that's worse that way. Come out, you twat. What have we done now? This wire is really stiff on here. This one. Right, I seem to have had them in the right way around to begin with. I wasn't sure for sure. My back is killing me again. Always does when I'm leaning over this damn thing. Well, it's steady 51 milliamps and we're at 4,000 RPM, so that's pretty good. I was expecting something like that. Yeah, those concentrics on the front end aren't really helping me very much. Well, we're at 50 milliamps, and yeah, I wasn't expecting to get too much, but yeah, I would have hoped it was more than that. Let's take this middle section out of phase, out of switch. Let's 44, stop it here, check the other one, check that one out. That's 49. Take this one off. That's 32. By switching each section out, because it's wired across to the next stage, by actually disconnecting, switching them out with the switches, it gives me an idea that we've got the system balanced right. Yeah. Very interesting that. The supercapacitors are about 4.36 volts at the moment. I'll switch over to LED mode. Got some LEDs down here which I'm lighting up now. They're not very bright. I don't know if you can see them. Probably can't see them very well, but they're actually near my hand. Yeah, that's about 40, that's 21 milliamps into them. Right, I'll switch it back to the supercapacitor. Oh, I've seen 30 milliamps up there. But yeah, we lose a bit because it drives the meter as well. Yeah, I'm going to have to take them front end concentrics out, but we're not getting a lot of drag actually. It's pretty good because yeah. Still more work to do. There's always something else to do. I'm streaming from the Adobe Flash Media Live encoder right now, so I can't see any chat on the stream. So if you're trying to talk to me on YouTube, I can't see it. But that's pretty good input current, 310 milliamps. 210 milliamps to 4,000 RPM, and that's not bad really, considering that we don't have a lot of drag on the system at all. We are driving it pretty lightly as well because it's such a low current. Somebody's watching at the moment, let's check. Actually, Ray's there. Yeah, there's always something to do, Ray. I'm just checking the chat at the moment. Yeah, I had the idea that I'd stick the concentric magnet arrays, which would help, but let's see where I've got the other ones, if I can find them. So at the moment, these haven't got magnets in, but I'll give you the rough idea. I'm finding this coil line around. I'll just use a bobbin. Yeah, I'll find one. Oh, it's over there. Yeah. Give me a sec. Let's get past here. Right, at the moment, the coil in the unit is, I've got the concentric at the front and at the back, and the trouble with that, the trouble with having the magnet arrays at the front and the back is they do compensate for drag, but they also block a lot of the flux lines which I want to pass through the coil from the rotors that pass by. So I'm going to have to remove the one on the front end and leave just the one on the back end. And it was working like that pretty well before, and that's when I had the acceleration, and I've decided to try one on the front end, and obviously we're not seeing acceleration when it's under load now. So yeah, but obviously I've got the additionals of my my lamination arrays, which are actually on the front end as well now on there. So I've got the lamination array plus the concentric, then the coil. So I'm actually losing power in that section. So that needs to come out, and then I just need to put my lamination array back on. I've got to do all 8 of them actually. So a lot of batting about to do, but it's still good though. I mean, when you think about it, we're drawing 50 milliamps and I'm not losing much RPM at all, really, very little. Yeah. I can boost the speed up for a little bit, but my current limited power supply might cut me out. But I'm going to boost it up a little bit. I'm going to take it up to 25 volts. So at 25 volts now, well, we will be when the current limiting circuit catches up. It'll pick up slowly because it's being current limited to about 300 milliamps. I could take the current a little bit higher, I suppose. Hang on. I don't take it too high, otherwise I'll overload my current limiting on the other end, which is on the input side. See, there's a certain threshold that you go past. There's a certain threshold that when you achieve it, it's like a unity point where when you get to a certain threshold point, that's where things start to accelerate and the power output just goes up exponentially, because that's when my circuit operates properly. And I'm not at that unity point, I'm not at the optimum speed right now. I'm running a bit slow, and it's all about resonance of the frequencies of the coils and the capacitors and everything. It's a tuned circuit, so the tuned circuit needs to be in tune, if you know what I mean. If it's out of tune and I'm running too slow, I don't achieve that unity factor, you know, where things start to resonate and work properly. It's a bit like when you're driving a car. If your RPM is too low and you're going uphill in say 4th gear, the engine will stall out on you. It's a bit like that, really. I don't know how else to explain it, but and I don't have any gears on this thing, so I can't change gears. Yeah, well, 61 milliamps, so yeah. I don't think we're still picking up speed though. So I've got the chat open. I'm happy with that, the lack of current consumption. That's really good news. I mean, these things don't even get warm really. My drive coils are a lot better. Let's tweak a little bit. I'll turn this end down a bit because these need to be on, otherwise it won't work right. Right. I haven't got my coils all matched properly yet. There's another thing, I haven't wound all the coils yet for I have some more coils to wind which needs to balance everything out. So I need to wind another 4 coils because I've done 4 coils on here, but there's another 4 that need to be redone to balance everything on the input side, because some of the coils, generator coils, are actually weaker than the others, so it's causing a slight imbalance in the system. That's why these LEDs aren't coming on here. I don't know if I flip these around. Let's flip these around. Where's my head? Squeeze. I'm getting some very interesting vibrations at the moment. I mean physically. Interesting. Yeah, that's subtracting. So when that coil is subtracting from that coil, so let's reverse this one. No, that wasn't the one. Well, that's 60. Turn that one back around. Forgot which way around it was now. Oh, that's that tight one. I hate taking that one out. I need to sort that socket out because it's not right. You know, one thing, we're seeing less drag than we did before. I'm not seeing much of a change on this RPM at all when I'm doing things. Yeah, and the super capacitors are back up to 5 volts right now. Interesting. Yeah, I need to get these coils sorted out because they're not balanced right. These two are turned up pretty high. This one's backed out. These two are backed out quite a long way. Well, let's put it this way. From looking at it at the angle I'm looking at, these two are at 3:30 o'clock. These two are at 2:30 o'clock or 2 o'clock. No, 2:30 maybe. 2:30 o'clock. These two are at 3 o'clock. These two are at 3 o'clock. So yeah, there's definitely some balance issues with the coils I need to get right. Oh, it's warm. I've knocked my current down a lot now. Let's turn these all to 6 o'clock. The had interesting results when these were at 6 o'clock previously. Right, I'll put them all at 5 o'clock. At 5 o'clock we only have 23 milliamps. So yeah. But we're picking up speed at 23.7, 28.8 we're finding. Go on, boil it. Got some vibration from somewhere. Right, let's go to 4:30. Or is it 4 o'clock on me? Right. 3.5. The triacs aren't firing at the moment. I'm going to go to 3:30. Noon, by the way, is off. It's pointing straight up. It's where the preset's off, basically. 6 o'clock is midway. Because I'm looking at this upside down. Yeah, I definitely need to get them concentrics out. Three o'clock. Let's go to 3:30. Well, look, we're at 4,500 right now, so we've picked up speed and we're about, it's all about tuning this thing. So these are going to have to be slightly offset to where the others are. Yeah, this one, this one's subtracted. I'm going to swap this around again. Well, I think it was better before when I had it, these two reversed the other way. Just a minute. Put this back as it was. Oh, where is it? Yeah. Yeah, I'm going to flip these around again. That's one. Actually, it was better the other way. Interesting. I'm getting backache now. Yeah, until I get them, until I get the generator coils all the same, it's not going to work right. Anyway, that's it basically. I'm going to have to I'm going to rewind some more generator coils and take those concentrics off. I've got plenty of wire to do with that with. Got in right? Don't think it was. I don't really like having the board on top of it because it vibrates too much. The capacitors are vibrating. Everything vibrates. Yeah, you can see the imbalance when I switch that coil out of this one. There's a big difference at this end, whereas there's not much of a difference at these ends, so there should be equal differences. Ah, yeah. Oh. Put this one around. Yeah, see, that made a big difference just working that one around. Yeah, that seems to be the best way at the moment, the way it's configured like that right now. Well, because I've got best current with that setting and best RPM with that configuration, so I'm going to have to sort them out anyway. More work, more coils to wind. What was I do? Hang on. So, if I take the light, cast a shadow, you can see that these LEDs at the bottom, they're just slightly lit. All of these LEDs should be evenly lit. These LEDs lighting up there, these dim, tell me that the system's not in balance, because this triac on this side is firing more than these triacs, these other 6 triacs, because there's 2 triacs per channel, each for each half cycle, and these 6 down on the back of here aren't firing the same as this one. So yeah, you can see it when I cast a shadow on there, a bit better. Anyway, let's take the load off, right? I'm going to take this load off and we'll see how much difference there is on the RPM. So I'm going to disconnect the output now. Notice that the input current doesn't change. I could have just done it with this lead actually. It'd be a lot easier than just set this lead out. Right, so we can see that we gained a few hundred RPM actually by doing that, so the system's still not right. It seems to be stabilised again now. Let's plug the load back in. Now we're seeing more LEDs come on. So let's back it out so these go out. Let's take the load off. I'm trying to hit that sweet spot. Load back on. Anyway, I think I'm gonna end the stream for now, because I've got some tuning, I mean some coils to wind, and I've got to get the energy up to do that, hopefully in the next few days or so. But I've got to get a new fridge. Got to get a new fridge sorted out this week as well, so I've got a few things cut out for me to do. Yeah. Anyway, I'm going to turn off the input voltage and I might actually I'll just turn the driver side off probably actually and just let it. Yeah. That's not on there, right? Knocks it a bit. I like this setup though because it's easy to unplug the coils and take this board off. It's a lot less farting about, and I can just unplug all these, take the board off, and I can get access to all my coils underneath, you see. So much easier to sort things out than it was before with them little wires going all over the place, and I've got the pull wave rectifier underneath there as well, which is a lot easier to get to. So yeah. Right, anyway, that's it for now. I'm going to turn this off. I'm glad I don't need to use cooling on this thing anymore. That's one good thing. It's a lot easier to work on. I mean, it's just overheat when it's used to. Let's check temperature through the side of here. 30 Celsius. That's the temperature at the side of the coils, and I can't feel any heat. 32 Celsius. I'm happy with that. It's not burning up like it used to do. Yeah, I don't know if I can tilt this over without this falling off, but let's try that. See if I can. I'll hold it with my finger. I'm going to get the temperature reading underneath. 42 Celsius directly on the coils. 35 on the other one. That one's about 42, which is perfectly acceptable. That's colder than a cup of coffee anyway, so I'm happy with that. Yeah, it's not getting hot at all really, which is a good thing. Yeah, so anyway, when I get them new coils wound, I've got to find out which ones I need to change actually, but part of the issue is the concentrics which are blocking a lot of the flux. But once I get the new coils wound, I'll just find out which ones I've done because I've forgotten now. All I have to do is measure the DC resistance of the coils to find out which ones need to be changed, and I'll soon figure it out. Let's get this RPM meter put back in its proper place. Turn the juice off of these supercapacitors that are driving this, will take ages to go down, take ages to discharge. I don't know I've got the oscilloscope still hooked up because I'm not even got it running. I'll take that off as well because it just creates more obstacles. I've got to sort my coils out and find out which ones I need to swap. I'll just wind. See what I'm doing is I'm winding new coils with 700 turns, you see. So the new ones are going to have 700 turns of the 30 SWD wire on the new bobbins, which are a lot taller than the old ones. Yeah, it doesn't take long to wind them, it's just stressful. I get a crook in my neck when I'm leaning over because I have to do it on my reel-to-reel, you see. Oh right, I've got big watches. Oh, well that's nice. Thanks, yeah. Well, one of them's probably me, I'm probably watching myself. I don't know. I'm logged in, so I don't know if it would ignore me or what, I don't know. But yeah, as I say, I'm having some interesting results with these new laminations. There's definitely an improvement with the laminations, that's for sure. I've got these other laminations over here. Well, these have got magnets in as well, and they seem to make. They were for the driver's side, but I'm no longer using those because I didn't need them on the driver's side. But I was trying to explain in a previous video that I drew this diagram. You know when you go in the countryside and you see one of them big power pylons, right? And they've got a guideline, a steel wire that comes to the top, from the top of the pylon to ground. And if you bang the pylon with a stick, it goes twang, and the vibration goes all the way to the top, comes back down to the bottom, and goes back up to the top. So the waves travel along like a long string. The waveforms basically resonate all the way down this long string. I was explaining earlier in the other video that that is the principle on how this circuit works, if you understand how a delay line works, that we're off phasing the drive current onto a following stage to overcome the drag, so that instead of having drag on the system, we will have an acceleration. On the previous video where I actually titled it Success with New Laminations. So if you haven't seen that one, you'll actually see that one where it actually accelerated. That was when I got these coils set up in a specific way, and I didn't have the concentrics on the front end, which I have at the moment, which I really need to take off again because they're just not serving a good purpose. I need to take the concentrics off, and I need to balance these coils out more so that I actually get more even voltage through the whole system, and then we should see much better results. And there's also some peculiarities with these triacs, because these triacs are they're asymmetric, which means they don't work in a linear fashion on both half cycles, and because they're asymmetric, it introduces all kinds of problems with the phase shift. So when you get a positive phase going one way, the negative phase might be delayed more than the positive phase because of the asymmetric. Symmetric. I can't say the damn word, but you know what I mean. So I've got them issues. Now there is a solution to that, and that is to stick a diode on the drain. I think it's a drain. The triac, so we can counterbalance the asymmetry, so that we have a more even switching. Oh yeah, Phil could be on. Yeah, he might be on. Well, I'm live streaming using a dual flash media live encoder, and it's a bit weird. The audio's a bit crap on it, and the chat doesn't really work that well. But yeah, I'm definitely happy about the drive circuit. I mean, it's a lot better. There's much less current consumption on the input side. But you know, I'm not worried that I've lost a bit of RPM by having the current reduced, because remember, when this thing is working properly, it self-accelerates, right? So when we get this circuit running right, it should self-accelerate itself. So I won't need to have more input current anyway, so it should start to accelerate by itself once we get it all balanced out right. So the drive current is really a priming current. It's really a priming pulse circuit current, so that it can run. And the actual secondary circuit, the output side, should, like it did in the previous video that I made, I'll try and put a link in this video to that later on, because things tend to scroll off otherwise, but it should actually accelerate even more once we get it balanced out, because it has been doing that. I gained quite quite a few hundred RPM, I think. No, was it? No, maybe it was 100 RPM, I can't remember now. I'll have to look at the video again, but it definitely gained speed when it was under load, so... yeah, I'm boiling. It's humid. We've had thunderstorms the last few days and it's been really sticky and horrible, and yeah. Also, I was saying in the previous video, I need to get the drive circuit, which is on these two boards down here. I don't know if you can see them really, but the drive circuit is down here. I need to get all this on one board, and I took it all underneath out of the way so I'm not farting about with these wires dangling about, because I hate having wires dangling all over the place. It makes it more portable, you see, because then you can move the whole thing around without trailing things. Yeah, so anyway, I'm gonna go. I'll see you in Discord chat. I'm going to watch some more videos on snooker or something for now. Yeah. I'm drinking black coffee, look, because my fridge is broken and my milk keeps going sour, so I've resorted to drinking black coffee because I'm sick of my milk going sour on me. These thunderstorms seem to make it go sour even faster as well. When I was younger, my grandma used to say, well, it's the milk's turned because of the thunder and lightning. There's probably some truth in that, actually. So, yeah. I'm watching a lag, it's way behind. Anyway, I've got to go. I keep saying that. We'll talk later.